Hi everyone. Today our video is about streams and monads. Let us look what is streams and monads. First we will look input output has side effects by definition. Side effects can be found in traditional input output. Side effects due to changes in non-local variables in memory region shared between functions. In built-in functions read multiple calls to display. One way to avoid these side effects is to model input and output as streams. Okay. So streams are unbounded length list whose elements are generated lazily. So streams are unbounded length list whose elements are generated lazily. To drive execution, language implementation, repeatedly evaluation of the car of the output, prints it and repeats it. So this is an example. Define driver lambda s. If null s, nothing is left. Then display car as driver CDRs driver output. So to drive execution, language implementation, repeatedly evaluation of car of the output, prints it and repeats. Suppose we want to write a purely functional program interacting input output with the streams that prompts the user for a sequence of numbers one at a time and prints their squares. If scheme employed lazy evaluation of input and output streams, then we could write define square lambda s cons please enter a number, then let n chars if end of object n cons star nn cons squares CDRs define output squares input. We will look what this program will do. The prompts, inputs and outputs would be interleaved naturally in time. Lazy evaluation would force things to happen in the proper order. The last line, define output square input, will take car s as the first input and evaluate star nn for squares and prints the output. Square CDRs will be considered repeatedly for the further evaluation until n found as the end of the object. Next we will look what do you mean by monads. Monads are drawn from a branch of mathematics known as category theory, but one doesn't need to understand the theory to appreciate their usefulness in practice. In Haskell, monads are essentially a clever use of higher order functions coupled with a bit of syntactic sugar that allows the programmer to chain together a sequence of actions function calls that have to happen in order. Stream formed the basis of input-output system in early version of Haskell. So what are the disadvantages of streams? It doesn't work well for graphics or random access to files. It is difficult to accommodate input-output of different kinds in streams. The solution is for this disadvantage is monads. More recent versions of Haskell employ a more general concept known as monads. Monads are drawn from a branch of mathematics known as category theory. In Haskell, monads are essentially used in higher order functions that allow the programmer to chain together a sequence of actions, like chains of function calls that have to happen in order. Monads have the capability to carry a hidden structured value of arbitrary complexity from one action to the next. In many applications of monads, these extra hidden values plays the role of mutable state. Difference between the values carried to successive actions taken as side effects. As immutable object is an object whose state cannot be modified after it is created, whereas mutable object which can be modified after it is created. In most Haskell monads, hidden state can be explicitly extracted and examined. Input-output monad is a type of monad meant for input-output tasks where only part of the state is defined in library header file. The rest is implemented in the language runtime system. Monads provide a general-purpose solution to the problem of threading mutable state through a functional program. So we will look what is map function. In Haskell, monads are essentially used in higher order. Map is a higher order function. Strings in Haskell are simply list of characters. The map function takes a function f and a list L as an argument. and returns a list that contains the result of applying f to the elements of the list. For example, so map plus 7, 1, 2, 3, 4. What will be the output? So this plus 7 is applying to all the numbers in the list. Then the output becomes 7 plus 1, 8. Then 7 plus 2, 9. Likewise, this plus 7 is applying to all the numbers in the list and the output becomes 8, 9, 10, 11, 12. Here plus 7 is the function f and the 1, 2, 3, 4, 5 is the list L. So we can see another functions using map. First line is the function initialization. So the symbol stands for is of the type. So map is of the type defines a function from A to B. Then square bracket in A is given in a square bracket. It means a list of similar elements entity written after last is the return type, always return only from one entity. This square bracket denotes empty list and the underscore denotes anything. Then H colon T is used to take out elements one by one from the list. H is the first element head and T is the remaining list tail. And the colon stands for concatenation. The third line is taking each element from the list and applying function f then and concatenating with the remaining list. The functional composition of actions in input-output monad. The most basic output action is putchar of type putchar. Putchar is a monadic function with an explicit character string and no explicit return. Put string, input output, print s, sequence, map, putchar s. The first line is function initialization and the symbol stands for is of the type. Given putchar, we can define put string. Result of map putchar s is a list of actions, each of which prints a character. Then sequence prints is a list in a single action. So the entry point of Haskell program is always the function. It has the type input output. Because Haskell is lazy, the action sequence returned by main remains hypothetical until the runtime system forces its evaluation. For a program whose input output can be expressed in terms of streams, the top level structure map consists of single line as given below. So main is equal to interact my program. Features of interact function. The library function interact is of the type string, tends to string is the input output. It takes as argument a function from string to strings. In this case, my program. So it calls this function passing the contents of standard input as argument and writes the result as standard output. Main is equal to interact my program. Next is higher order function. We will look what is higher order function. A function is to be higher order function. It takes a function as an argument or returns a function as a result. It takes function as an argument and returns function as a result. So various higher order functions are there. There is a map function. Map function in scheme takes as arguments as a function and a sequence of list. It takes in two inputs, function and list. It then applies this function to every element in the list and returns the list that contains the result of applying f to the elements of list. There must be many lists as the function takes arguments and list must be all of the same length. So syntax is map function list. Various higher order function is there. Map is purely functional. It returns a list composed to the values and returned by its function argument. Map calls its function argument on corresponding set of elements from the list. So map star 246 357 it tends to 6 20 42. Map plus 1 the list 1 to 5. We are adding 1 to each element and the list becomes what? 2 3 4 5 6. So another function is map to lower a b c d e g f g 12 as you can see in the screen. What it is doing? It converts all the characters to lower. Then map mode 3, then it is applying to the list 1 to 10. It becomes, the list becomes, the output becomes like this. So map is a what? Map is a higher order function. Then another is folding. That is folding reduction scheme. Fold function. Fold takes in a function and folds it in between the elements of a list. To fold the elements of a list together using an associative binary operator. This picture illustrates right and left fold of a list visually. It is you can see that uh, right and left fold of a list visually. So let us add up to first 5 numbers with the fold. The command for this is given as fold plus 0, 1 to 5. First take the elements of the list and write them out separately uh, with a space in between this. To fold the function into the elements, write the function in the empty spaces between the elements. Before the first plus, we can specify a starting point. So all this gives us the final result. Fold plus 1 0 1 to 5 becomes 15. If we change the starting point to 1, then what will be the plus 1 will is added to 15, it becomes 16. If the starting point is 10, what is to this list, 10 is also added, then it becomes, value becomes 25. Then fold maximum 0 3 10 46. In this we are finding the maximum value in the list of numbers, it becomes 14, is same as max 0 3 10. Fold function. Fold takes into function and folds in between the elements of the list. To fold the elements of a list together using an associative binary operator. Now fold plus 0, 1, 2, 3, 4 gives the sum of first 5 natural numbers. Fold star 1, 1, 2, 3, 5 gives us their product. So next is fold in reduction scheme. Fold 1 and fold R functions. We can also go through the first fold left and fold right function. Sorry, fold L and fold R function. We can also go through the list from right to left rather than left to right using fold R and instead of fold L. Example, with the plus get exactly the same result since 0 plus 1 plus 2 plus 3 plus 4 plus 5 exactly same as 0 plus 5 plus 4 plus 3 plus 2 plus 1. There are cases where folding from the left gives us different result to the folding from the right. Combining higher order functions. One of the most common uses of higher order function is to build new functions from existing ones. So define total lambda plus 1, fold 0, 1, total 1, 2, 3, 4, 5, 6, 5. The output becomes 15. Then another example is given. So it takes function total L and list L which folds the elements of the list. So next another is what is currying. Currying is the methodology of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions, each with a single argument. So it takes a function with the multiple arguments and then evaluates it and it gives a single result. That is currying. A common operation to replace a multiple argument function with a function that takes a single argument and returns a function that expects the remaining arguments. Functions can be classified on the basis of the number of inputs they accept. Binary functions will take 2 inputs, while a unary function will take a single input. In Haskell, every function takes only one input. So function in Haskell can be set unary. Is it possible to implement a function which takes multiple parameters? Is it possible by a methodology called currying, named after Haskell Curry, scientist who made this methodology popular and invented Haskell. In currying, curry function takes only one argument and returns a function. A simple example of currying, so plus is a function which adds two numbers. We wish to add two numbers x and y. X will be the input to plus and returns a function named plus x. Plus x function takes one number, add x to it. So this is a normal implementation function and we can see the implementation of curried function. A common operation to replace a multiple argument function which takes a single argument and returns a function that expects the remaining arguments. Define carried plus lambda, lambda b plus ab, carried plus 3, 4, it gives to 7. Define plus 3, carried plus 3 plus 3, 4, it gives the value 7. This is how carrying is applied. Another, among other things, carrying gives us the ability to pass a partially applied function to a higher order function. Map carried plus 3, 1, 2, 3 gives the value 4, 5, 6. General purpose carry function is there. We can write a general purpose function that carries its function argument. Define carry lambda f, lambda s, lambda b, fab, carry plus 3, 4 gives the value 7. Define carry plus tuples as ML function arguments. ML and its descendants Miranda, Haskell, Camel, F hash make it especially easy to define carried functions. In the ML interpreter, the inferred type of plus can be described as a function of two arguments, but the ML function defines all functions, takes a single argument. Function plus AB int gives a plus b, value plus function int star int gives int. Tuples as ML function arguments, what we have declared as a function that takes a two-element tuple as argument. To call plus, just pose its name and tuple that is argument plus 3, 4 gives variable it is equal to 7. Optional parameters on singleton arguments, we can declare a single argument functions without parenthesis formal argument. Function twice n int n plus n, value twice is equal to function int twice 2, value is 4. Simple carried function in ML. Now consider the definition of carried function. Note the type of carried plus int in the groups implicitly as int. Function carried plus a function b int is equal to a plus b. Value carried plus function int is equal to int. Where plus is a function mapping a pair of integers to an integer, carried plus is a function mapping an integer to a function that maps an integer to an integer. Carried plus 3, it gives the value variable it is equal to function int star int. Shorthand notation for carrying. ML allows a sequence of operands in the formal parameter position of a function declaration. It does not declare a function of two arguments. Carried plus has a single formal parameter a. It returns return value is a function with a formal parameter b that in turns return a. Function carried plus ab is equal to int a plus b. Value carried plus is equal to function int. So I will come with the next video. Till then, bye.